So in this talk, I will just go over basically what Mechatronic is as a course, some of the projects that we do, and just kind of like what kind of careers you can expect from it, and just my experience of it so far. So the first question a lot of people ask is, what is mechatronics? When I first was in secondary school, I didn't know what it was until I came to a DCU talk. Not many universities do it. It's the combination of mechanical and electronic engineering. So basically, it's mechanical devices that are controlled by electronics. So this is a lot easier to explain when shown where this is. So an obvious example would be, robotics. So they are moving parts and they have a computer that controls them. But you also have, drones and more modern day appliances like your inkjet printer, your PlayStation controller, electric cars, and even like smartwatches. Smartwatches would have, sensors. They can track your walk, your heart rate, all of this. So all of these are great examples of what mechatronics is and what we learn on our course. So in mechatronics, you will learn both subjects from the mechanical school of engineering and the electronic school of engineering. So where you can get into. So some of the your future and your careers, since as I mentioned, it's a combination of mechanical and electronic. So it's a really diverse course. So pretty much if you had a table of electronic engineers and mechanical engineers at one table, both talking like nearly their own languages, you're going to be the person be able to be in the middle and be able to understand both and be really good for that teamwork, be able to bring everyone together. So for careers, you can have like technical positions, you'll have amazing problem solving skills, design skills, and also transferable skills. You'd also be recognized internationally with your chartered engineer status, which pretty much means your degree will be recognized and also respected where you go to apply for work. There's also progress into management, further qualifications and research, but it doesn't necessarily have to be directly for engineering. You learn really valuable skills in this, and also a lot of tech skills that can be used in other career areas. So the course structure. So this course is 4 years, but if you choose to do an integrated master's, so it becomes 5 years. So pretty much it's just a slightly different course. You get to focus on your a couple different subjects with your master's, so it's slightly different. The main difference would be your placement. So in all of the engineering subjects and courses, you have a placement in third year. If you're just doing your degree, it's 6 months. And if you choose to do your integrated master's, it is 10 months. I'll go into the placements a little later at the end of the PowerPoint. So your course will be a mix of continuous assessment and exams. They'll be different for each module and they change every year, so I won't be able to tell you the specifics. But obviously you'll have your big projects every year. You'll have a bunch of teamwork that'll all contribute to your end grade. You'll also have 60 credits per year, so that's pretty much all of your subjects are worth a certain amount of points towards your overall end grade. So in this course, you have 8 core areas as seen. So you have like basic science, mathematics, electronic circuits and system design, mechanical system design analysis, software design, mechatronic, electromechanical system design, automated manufacture, project-based learning, and experimental learning. These pretty much mean that you'll have your lectures, you'll have your teamwork, and project work. So you'll go into a lecture one day, you got to learn a bunch of information. You'll have a tutorial then later on the week where you'll get extra help going over information, doing questions, and then in some of your modules, so subjects, you'll have a lab. This means you'll be able to go in and actually use what you've learned and apply it. This is really useful, so it means you don't just have all the theory, you also know how to use what you're learning. It's a really valuable skill, especially when you leave university and go into the workplace. So these are some of the module titles. So a lot of them won't mean much, but if you just have a look at the year one, you have your professional development, technical drawing, you have your maths in there, your basic sciences. This course, which has a common entry engineering, so everyone, regardless of what you choose, you do the same first year as all the engineering courses. But you all start from the foundation up. So you'll learn your basic sciences, you'll learn your maths from bottom to top, as well as your workshop skills. You are not expected to know any workshop skills or programming or any specific science. You will be taught all of that. So the perfect example is when we go into our projects. So in engineering, we have a lot of really cool projects that we work on. So the first year, your big project is your automatic guided vehicle. This is pretty much a small self-driving car, as you can see in the picture in the bottom right corner. You are put into groups and everyone has different experiences. They deliberately put people who have had different leaving cert subjects together so you can come at it at all different angles. You're in control of the design of the car and you get to develop all the skills involved in it. In second year, you get to design a robotic arm for a production line. So this is just all on your computer. It's with using a software application. So I'll show you some images in a minute, but it's a really good project you do in a group of 10. For the third years, I'm only in second year, so I haven't done these ones yet, but mobile robotics is a more complicated version of your self-driving car from first year. It can do more maneuvers, it can do more things, and it just pushes you that bit more further. Fireman Challenge is also shared with a couple of the other engineering courses, and it basically means you have to carry a glass of water while your robot climbs up a ladder. I can't do that. If I'm walking up the stairs at night, I'd spill it everywhere, so try getting your robot to do it yourself. It is quite a challenge, but it's very worthwhile when it gets completed and starts working. So here we have just the AGV project. So it's just showing from start to finish. On the left, so this is my project that I did. So on the left-hand side, you can see our initial SketchUp and what it turned out to be. The initial sketch there, we did it on SolidWorks. As you can see, it's not very realistic. It's quite blocky, but it gives you the idea. By the end, just even halfway through second year, your skills for digital design will have improved to this. Especially the one in the top right corner, you can see it's a lot more realistic. So this was the robotic arm that we designed as a project this year. You can see that we're integrating more circuits and gears, and it's a lot more complicated. So this just shows the development that you can expect just from first year when we're starting from the foundation up. This is another example. It is one from a past pupil who's also doing mechatronics. I won't get into it because it is way too complicated, but it just shows you how it goes from the concept to design and to the solution. So the intra-work placement. So this is in third year. As I mentioned earlier, it is for 6 to 10 months, depending on if you're doing your integrated masters. Many students choose DCU because of this intra-placement. Most courses in DCU do offer some placement or another, and it's really valuable because it offers real work experience. It looks great for your CV, and you can get placements in abroad or Ireland. Some of the companies that have deals with DCU to do these placements are on the screen here. Even if you're not doing biomed, I know mechatronics students who have ended up in places like Pfizer because all these companies have some amazing equipment, amazing machinery that mechatronics students overlap. As I said, it's a really diverse subject and really useful for that. The requirements. So you have the general entry requirements for the university. You can find those online. You need a minimum of H4 maths or a minimum of H4 in applied maths and a H5 in maths. And then mechatronics from last year, the minimum is 501 points. So you can pop any questions you have into the chat there. And if you think of any questions later on after this, those are the 2 emails you can contact for information from the schools. As mentioned just in one of the earlier talks, if people missed it, there is an engineering society. So the engineering society allows you to explore more of the it's a social side of engineering, but you also get to try, projects that aren't academic. If you're interested in 3D printers, remote controlled cars, drones, all that, they've explored all those projects just outside of their modules. It's just in their own time. So engineering is quite a full-on course. It does vary slightly about the amount of hours, but you would expect a few full days during the week. You would be on campus every single day unless you have online classes. Depending on labs, that can also change. So for some days you might not have anything, or might only have one class because your lab is every 3 weeks. You don't have your labs every single week. So especially for project work, they'd assign you something and you might have 3 weeks to work on it, and then you'll come back to the lab and actually start assembling. This course has a lot of pair learning from it. So if you don't know the answer, it's very much encouraged to talk to other people in your course. And if you don't know it, someone else might, and you get to help each other along. And it's, even if it's quite heavy in the amount of hours that it does have, it makes it a lot easier to make friends and meet people on campus, which there are plenty of societies to get involved in as well. As I said, if you think of any more questions, the emails there are on the screen and you can contact them for any information regarding this, the mechatronics or the other engineering courses. That's time. So thanks for coming. And hopefully some of you might consider mechatronic engineering.